Hello! Today in the lesson, we will solve some more examples using the properties of degree. First example, 2 to the power of 5 is multiplied by 8 and multiplied by 16. We need to find the value of this expression and write the answer in the form of a number to some degree. To do this, we have to use the properties of degree. Of course, we can take 2 to the 5th degree, multiply that result by 8, and then multiply by 16, and we have a number. But the assignment tells us to write the answer as a number to some degree. And then we need to apply the properties. But the first multiplier has a base of 2. The second multiplier has a base of 8, and the third multiplier has a base of 16. If we say that the exponent of the exponent, the number 8 is 1 and the number 16 is also 1, I can't apply either property. Why not? Because the bases are not equal. I can try to write the number 8 as 2 to some degree, and the number 16 as 2 to some degree. Let's try it. Let's write the number 8. If it's 2 to some degree, I'll do the math. 8 is 2 times 2 and multiplied by 2. Indeed, 2 times 2 is 4, 4 times 2 is 8. Then 8 is 2 to the power of 3. Let's try. I'll try to write the number 16 as 2 to some degree. 16 equals. I need the number 2, 2 multiplied by 2, 4 multiplied by 2 again, 8 multiplied by 2 again, 16. The result is that 16 is 2 to the degree of 4. And then I can solve our example. 2 to the power of 5 multiplied. Instead of the number 8, I'll write 2 to the power of 3. Multiply. Instead of the number 16, I will write 2 to the power of 4. And now, the bases are equal, and then I can apply the first property. The result is 2 to the power of 5 plus 3 plus 4, 2 to the power of 12. And that would be the answer. When you're solving these examples, it's difficult when you're to determine which number to raise to what power. You just have to count and try. Now, we're going to solve one example where I'm going to show that the same number can be represented different numbers to different powers. The example looks like this: 16 times 64 and multiplied by 256. As you can see, we can't apply the properties of degree either, especially all the numbers are written without exponent. 16 in the first, 64 in the first, 256 in the first. So we're going to try and find the number that will be the base of all the multipliers. Let's try to use the algorithm that we used in the first example. And in the first example, we represented the number 8 as 2 to some degree. And we calculated that 8 is 2 to the 3rd degree. So then, in our second example, let's try to write 64 equals 16 times 16. But 16 times 16 is 256. That's not 64. It's 256. So you can't write 64 as 16 in some way. Then there's another way. The wrong way. But in the previous example, we wrote down that 16 is 2 to the power of 4. Let's try to write 64 as 2 to some degree. To do this, we'll do the math. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2. 60 64. Then 64 is 2 to the power of 6. 1, 2, 3, 4, 5, 6 to the 6th degree. 16 is 2 times 4 to the power of 4. 64 is 2 to the power of 6. And now the number 256. Let's use the same algorithm. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2. 64 multiplied by 2, 128 times 2, 256. Then the number 256 is 2 to the power of 9. 1, 2, 3, 4, 5, 6, 7, 8, 2 to the 8th power. Then I'll write 2 to the 8th power, and then I have the same base. I can apply our properties. The result is 2 to the power of 4 plus 6 and plus 8 equals 2 to the power of 18. But this example can be solved in another way. It doesn't always work out in the examples, but the point is that 16 is 4 times 4, then 16 is 4 squared. But 64 is 4 times 4 times 4 times 4. 16 times 4 is 64. So it's 4 to the 3rd power. And 256 is 4 times 4 times 4 times 4 times 4, and again times 4. That's 4 to the power of 4. We can write these numbers as numbers with a base of 4. Therefore, I can write down 16 times 64 times 256 equals. 16 is 4 squared. 64 is 4 to the 3rd power. And 256 is 4 to the 4th power. And then the answer is 4 to the power of 2 plus 3 is 5. 5 plus 4 is 9. Then the answer is 4 to the power of 9. But 4 to the power of 9 and 2 to the power of 18. Are these numbers the same? Yes, they are the same numbers. Why? In this case, we can apply another property. What property? 4 is 2 to the power of 2. And it's a power of 9. And then by our third property, it's 2 to the power of 18. We got the same answer. The point is that you can write down the answers depending on the situation. If this assignment tells you to solve an example and write the answer as a number 2, to some degree, you would write it with a base of 2. If they tell you to write the answer as a number with a base of 4, then you would write the answer as 4 to the power of 9. In the next lesson, we will solve some more interesting examples. And for today, our lesson has come to an end. Goodbye. See you again.